Hello and welcome back to Higher Maths Differentiation Stationary Points. So we're going to do another example here. So I'm going to go over the nature table again in a little bit more detail. So first of all, we have a cubic equation. It's a positive cubic equation. Now this will either look like this, where we have it rises, and there's a maximum, then a minimum, then it rises again. Or it might be a rising point of inflection where it rises, flattens off, and then just rises again straight away. If it's a negative cubic, so if this leading term is negative, it will fall, then rise, then fall. So we'll have a minimum, then a maximum. Or we might have a falling point of inflection, so it will fall, flatten out, and then fall again. Okay, so that's what could happen. So if we're thinking about that before doing the question, I know I should get a maximum, then a minimum turning point here. Or it might be a rising point of inflection. So looking at this question, those are my two possible answers. Right, let's have a go at doing the question. So find the stationary points on the curve. So it says points. So due to the question, I'm guessing it's a maximum, then a minimum. So I'm going to differentiate first, which should be quite straightforward. I'm then going to say dy dx equals 0 for stationary points, because I must always state that. So equate dy dx to 0, take out a common factor of 3, solve using my trinomial knowledge, and I get x equals 1 and x equals 3. And then step 3, find the y coordinates. So I know when x is 1, y will be y of 1. So just substitute 1 back into y equals, or f of x equals, if it was labeled f of x. Do the same again for 3, to find the y coordinate when x equals 3. Okay. So I've got 1, 0, and I've got 3, negative 4 at the moment. So this is actually the final curve. But I do know, because it's a positive cubic, we'll have to do this. So I could be thinking, I need to justify this in my answer. I can't just say it's a positive cubic, so it'll be a maximum, then a minimum. The SQA don't accept that. But I do know it's going to come up, peak at 1, 0, drop down to 3, negative 4, then increase again. So the nature table, so the new bit. So every time we have the x coordinates, we need two separate nature tables for this. The SQA insists on that. So my x values go along the top, so I've got a turning point at x equals 1, a turning point at x equals 3. dy dx, now I always write it in factorized form. Okay. Some teachers would just write down 3x squared minus 12x plus 9, which is absolutely okay. I'm not saying that you shouldn't do that. But because we're not actually looking for the value, we're just looking for the sign of the gradient, this actually saves us a little bit of work. So if I look before 1 and after 1, so relating it back to this, I'm looking at the gradient here and the gradient just after. I want to know if it's positive or negative. So if I substitute a number before 1, so if I substitute in 0, I'll get 3 multiplied by 0 minus 1 multiplied by 0 minus 3. So I've got 3 multiplied by a negative multiplied by a negative. That will be a positive value. So I know before 1, the curve is increasing. Substituting a number after 1, but before 3, so I can't just use 3, so I'm going to use 2. So 2 minus 1 is positive, 2 minus 3 is negative. So I've got 3 multiplied by a positive multiplied by a negative. That will give me a negative answer. So after 1, the gradient is negative, so the curve is falling. Let's just check that happens. Yes, it does. Increases, flattens out, drops. I should always just substitute in 1. So 1 minus 1, 0. 3 times 0 is 0, multiplied by anything is still 0. So it's going up, flatten off, coming down. So I'd say a maximum turning point at 1, 0. I need to repeat the process for x equals 3. So I've already looked at 2, so I can actually use what I've used here when x is 2. So I've got a negative gradient, so I know the curve decreases. Then at 3, substitute in here, 3 minus 3 is 0. So I've got 3 multiplied by a positive multiplied by 0. So a gradient of 0, so it's flat. And then any value after 3, so let's use 4. So it'll be 3 multiplied by a positive multiplied by a positive. So a positive gradient after 3. So it's going to drop, flatten out, and increase. So I'm showing that in my nature table of the slope. So all I'm doing is showing it in the correct direction.